Такие роба. Такие роба. Hello, everyone. We will start in 5. Not 5, sorry. It's a joke.
Hijo,
We will start in...
ya estás ya conéctate a ese Zoom o ya estás.
Hello, everyone. How are you doing?
Hello, hello.
Свет, нажми сейчас включить звук.
Со звуком все хорошо. Сейчас с фрезой надо разобраться. Okay, good. So hello everyone again. And before the start, we discuss the main rules for online. Please be attention about your microphone. Please mute all your microphones in your devices. Don't forget about ask your question in our chat in Zoom. And also today I would like to offer you and special offer. So please turn on your video channel and we will make a common photo. Today we repeat our tradition. We need to take a picture with you. Please turn on your camera. Hi, Bruno. Hi, Mario. Andrew, hi. Damian, hi. Guys. Okay, great. And my team, we will go to take a photo with you. Don't turn it.
Everyone.
Света, а куда мы все пропали и чего ждем?
We take a picture.
Так, when are we going, Steve? Damien, grace to you! And Jacques.
Where's that coming from?
Guys, thanks you for amazing picture. It was our daily tradition. Yeah, I know you like it too. Great, great. So let's continue our day 3. Okay, so let's start. Today we have day 3. This day with our classes about our autonomous flight introduction. And today you will be taught by Yulia Shishkanova and Timofey Kondratyev. Oh, sorry, this is a wrong slide from previous. Just a moment. Okay, great. Today we will provide our session for you, for team from Group B, Ecuador, Colombia, Barbados, Brazil, Portugal, and South Africa. So today you will know about indoor navigation system, what is it and how it works, what you need to get first programming skill using Python language, and also you will make a code debugging at our remote venue with your team coordinator. You will use our remote venue named Polygon. You will test your code on real drone, or also we will tell you about our Gazebo simulator and you will test your code on it. So let me introduce you with our organizing team for this day. Today, this day will be provided by Yulia Shishkanova and Timofey Kondratyev, our great teacher. Also, if you have any question or another problem with communication, you can ask our chief communication and interpreter, Ilya Hukhuni. He is here. And also, if you have any question, you can call me, of course. So also, our team consists of Anton Maltsev and Svetoslav Alekhin. These guys will help us in technical support. Victoria Trubitsina, she is responsible for our time management. Elena Silverstova, she will be make a launch and test your code on real drone. And Vladimir Voronin, he will be responsible for saving your drone during the autonomous flight. Okay, so, and some very important topics. Be friendly with your team coordinator. These guys will glad to help you and answer to your question, of course. And also, he will write you in Telegram group. And please, when they make ask you about anything, try to answer him too. And if you have many people in your team, please choose a group leader from your side. It helps us to coordinate you. Your team group leader will communicate with your team coordinator, and it helps you to save more time. And in the end, feel free ask me using my ID Telegram or your team coordinator. This is a simple scheme to help you to answer in many questions. And so Let's welcome our great teachers and have a good classes. Let's fly. Let's welcome Yulia Shishkanova and Timofey Kondratyev.
Hello,
Hi.
nice to see you again, some of you again. And let's begin. We will share another presentation with you, and I will teach you the basics of drone programming today. Are you ready, Yulia?
Yes, I'm ready.
Great.
Let's start.
Wait a second. All right, so this is our future skills session, and let's begin with what our drone is. So here is a quick short video that shows you the capabilities of our Clover drone platform. It is very flexible and powerful. You can do pretty much anything with it. It's limited by your imagination and maybe additional devices that you could put on them. So as you can see, these drones can be used in swarm robotics. They can be used for any type of autonomous flight. So you can see videos from different competitions. They may be all over the world, mostly in Russia, but we are expanding. So this is what a drone can do. It could be programmed to make autonomous flips and some other aerobatics maneuvers, and even autonomous flips in a swarm. Also, the drone is equipped with a camera that allows the drone to recognize some objects on the floor or wherever the camera is faced. And here, for example, the drone could be equipped with additional devices like a 3D sensor camera that makes a 3D model of person. As well, you can make a cargo delivery drone with Clover. And here you can see a magnetic electromagnet that grabs a metal piece and delivers to another place. This is actually a high school competitions. And now you can see a university's competitions that was in Spain. Also, the Clover drone was used in first in its kind performance in theater. So this is our Clover show, a project that was developed using our platform, and it shows how powerful and flexible it could be. Let's go next. So Julia, word to you.
Okay. Yes, but we use our Clover drone kit not only for competition and for different projects. We use it in educational program in Russia, for example, for mathematics lessons and for physics lessons, and another in school, universities, and college. So we create a lot of materials for it. For example, plan of lessons and educational materials in our site. In Clover site, you can open it through the link or through the QR code, and there we have assembly instructions and setups instruction and a lot of information about programming autonomous drones and about different projects what we create on this platform. And you can make something same like our users of this platform. So I think we should discuss what is a drone, what components it has the first one. It is SCU. It helps drone to understand where it is in air and check his position. It has some sensors, for example, accelerometer, barometer, and magnetometer, and it helps him calculate his position in real world. But it can work not very good, and then we can use the GPS module with the flight controller. The next one, it is the power distribution board. This model provides power from battery to each element on the drone, to electronic speed controller, to motors, to flight controller, to receiver, and another if you have it. So the next one, it is motors. We have brushless motors, and we have two types of brushless motors. It is clockwise and counterclockwise. So we need electronic speed controllers to control speed on our brushless motors because we need a special signal from VCU to set up speed on the motor. The next one, it is battery, of course. You can use 3 cells and 4 cells battery for our drone. And one more thing, it is a remote controller and radio receiver. But it is not very useful for our lessons because we will make our drone autonomous, fully autonomous, and you can use the remote controller only for manual control. But our drone will fly with special commands from microcomputer, and we don't need manual control. We don't need radio receiver. But we have it on our drone because if you have some mistakes in your code, or if drone will doing something unpredictable, you can take control for drone from remote controller. So I said we will use our drone fully autonomous, and Raspberry Pi microcomputer will help us in it. This microcomputer can calculate your position using special camera for computer vision with fisheye lens, and it can calculate X, Y, and Z axis. And we have rangefinder too to get a distance to the object or for or for another navigation system, and for example for optical flow. So we will use all these elements in our lesson, and you can read more about it through the link. And I think Timofey tell you about navigation system a little bit more now.
Sure. As Julia just said, we use a onboard microcomputer, Raspberry Pi. And here you can see what the computer sees through the camera. This is the debugging window of camera. And as you can see, it recognizes certain markers. Those markers are called Aruco markers. Here you can see how it spells, Aruco map. And we form them usually in a grid just to make a map with coordinate system. So as you can see, there is X, Y, and Z axis. that are they coming from certain position on the floor, and based on this information, Raspberry Pi will send that data with drone's position to the flight controller. But how does it all connect together? Let's begin with the flight controller. Here you can find a link to the information about PX4 firmware. This firmware is actually a software that runs the drone's flight controller. It is an open source project. You can find the source code on GitHub. So what it does is actually it gathers all the information from different sensors and from RC controller, from Raspberry Pi if you connect it the right way, from all the sensors that are built in the flight controller, like accelerometer, gyroscope, barometer, and so on. And this information is mixed together using filters. This way, the drone calculates its current position in the space. And therefore, it is capable of maintaining horizontal flight, stable horizontal flight. It can hover in place, and it can navigate through the space based on the mission points that are provided to the flight controller by Raspberry Pi, for example. So the Raspberry Pi has the software for working with computer vision. You can also find a link to it. And the computer vision is responsible for determining which marker is it, which number it has, and where in the map, in the coordinate system, these markers are. So I will tell you a little bit more about coordinate system just a few slides later. But on the Raspberry Pi, we have a Linux operating system, the version that is modified with pre-installed all necessary packages. For example, ROS is one of the most important packages. The ROS is basically the robot operating system. This system allows you to connect together all the different sensors and all different parts of a robot. In our case, this is a flying robot. And therefore, these systems can communicate to each other. They can send each other some data, and they can call, one program can call for other program to get some result. ROS is a very powerful system. It is also open source, and you can modify it the way you want, very flexible. And how does it work in terms of our drone? So ROS reads the data from camera. There is a special node that will read the camera image and find some squares with white squares inside, determine where the camera is located, where the drone is located. So there is a module that every time, in any given point of time, will tell you in which coordinates the drone is located. Then ROS passes this information to the flight controller using the MAVLink protocol. This is a protocol that this is a messaging protocol for connecting with your air vehicle, in our case, a drone. So MAVLink protocol provides the connection between PX4 software on the flight controller and ROS that is on Raspberry Pi. So Raspberry Pi sends data about where the drone is located, and the flight controller can use this data in order to maintain flight in certain position that is desirable in this moment. So this is not the only reason why we use Raspberry Pi. We also write our own scripts, usually in Python, and those scripts are also run on Raspberry Pi. And when you perform the script, you call for certain services in ROS, and those services will send commands to the flight controllers where to go. So the flight controller will receive two types of messages. The messages of current position and of the position where drone should be. I'm sorry. Okay, let's continue. So how does a drone determine where it is located? Let's talk about coordinate systems. So here's another picture where we see the image from camera and the diagram of where the drone is located in this coordinate system. There are different coordinate systems in the drone. It is better shown in this picture. Look at this. So here we have the map, the field of markers. They have the origin point here on the left, lower left corner. And you can tell for sure that 0 coordinates is here. So 0x, 0y, and 0z is in that point. And in any other point in this field, there are other coordinates. For example, if I move 5 meters to the right, then x is 5. Then 2 meters forward, where my y points, I'm in a coordinate 5 and 2. And then if I go up 1 meter, then I'm in a coordinate 5, 2, and 1. And now you can see that there is a coordinate system special for indoor flight. It doesn't use any longitude and latitude. It's not connected to the position on the Earth, but it's connected to the Aruka marker field in your room. But for the drone, it is also possible to navigate relatively to itself. So as you can see on this picture, we have a coordinate system that's called body. This system originates from the drone center position. And the z-axis is always pointing up relatively to Earth. So if you tilt the drone, the z will maintain vertical. This is important to remember. X-axis is heading forward and y is heading left to the drone. So this is the coordinate system of the drone, and it is used when you need to take off when you are on the ground and you do not know where exactly you are in the Aruka marker field. You do not know. You may put your drone on this marker or between these markers, and the drone will take off vertically from the point where it is located. This is what we will do when we start practice. Once you have taken off, you already see the marker field with your camera, and you get the messages, and the flight controller gets the messages of its position, and you can navigate through the space using the Aruka marker coordinate system. Okay, how does it work in code?
I think we should say one important moment. If you will use Aruka map frame for takeoff, your drone can take max speed and take off with max speed. So never time use Aruka map when you take off, because it can be unpredictable for you. If drones max.
I will show you what not to do, and I hope you remember that it is not what to do. So, so how does it look? How does it look in code? There are Clover services, and they are described in an article that is here. You can find it in this link, symbol of board. Basically, this article has a description of every service that's available in Clover. We will use some of them, not all of them, because we don't need all of them for now. So what are the most important services? First service is get telemetry. This service, if you call it either in a console in your terminal or in code, it will return you the information about the drone, like its coordinates, its speeds in each of the axes, its how it's tilted in the air, like yaw, pitch, and roll. And maybe you need to know the battery life, how much volts does it have right now. It is also always available using the get telemetry service. The most used service is navigate. You will provide the coordinates where to fly, the speed at which you fly. Then frame ID is actually the coordinate system that you are using. You need to provide it. And you can tell whether to auto-arm the drone or not. Auto-arm means that the arming is turning the drone on, like turning the motors on. And auto-arm means if the drone was standing on the ground without moving, and you call this navigate service, it will start motors. If you do not provide auto-arm in the first takeoff attempt, the drone will not fly. The next service is set position. I do not recommend you using this service yet because it is a little bit more advanced and a low level. So the main difference between set position and navigate is that you do not control speed of the drone. It may be dangerous. So if you tell, for example, if your drone is located here and you want to move 2 meters to the X position and you use set position, the drone will fly very fast between these 2 points. It may hit something, it may break or crash. So set position is mostly used in short distance moving and when you update the position very quickly. For example, if you update the position 10 times per second, then set position is what you need. You also can control speed of the movement because by the distance, by the delta distance of each set position point. The next service is land. This service tells the drone to land from where it is now vertically down. You can find more information using this link. And how do we do it from Python? You can find this sample code on the article that I just showed you. This is basically importing the necessary modules for the drone. For example, ROS-Py for working with ROS. And the Clover module is a special module for Clover. Then you assign the name to your ROS node. In our case, it's flight. And here you provide which services you will use in the code. There are many other services that I didn't explain you what they do, but you will not need them. So if you do not have, for example, navigate, if you didn't call navigate this way, it means you cannot use it from your code. You need to always provide the services. This is called a proxy. Let me show you in the article. So here is the code that you can copy and paste in your program. You will do it pretty much in every program because otherwise it just doesn't fly. And navigate is a variable, and we assign this value to the variable. So this is actually a service proxy, and we say navigate means that this means this service. Okay, And this is why it is important. You just copy it and paste in the place where you need. Okay. But before we write our first program, Julia will tell you about how to load it into the drone and how to work with Linux operating system that's on the drone. So Julia, you can start.
Okay. In our drone, we have a little bit unusual for you, maybe, system, because you use Windows, I think, or maybe Linux, or maybe macOS with graphical user interface. And when you turn on your computer, you can see all folders and all files, and you can easily open it. But in our image, in our system for drones, we will use only command line. And there we will make all actions with special commands. For example, if I want to see all folders and all files in current directory, I just write in the command line ls and press enter, and then you can see all folders and all files in this directory. You can see it at the right picture, first command. The next one, if I want to change directory or open one folder, I need to write command cd or change directory. This command allow us to open any directory if we write cd space and directory name. For example, cd space my folder. The next one, if I want, if I haven't any directory, I can create it. And for it, I will use a special command, mkdir. It allows to make a new directory, and you should write this command, and after it, press space and write directory name. You remove directory or maybe any file, you should write rm command. It means remove, but you can use remove file easy. But if you want to remove folder or directory and you have some files inside, you should use special prefix. The next one, it is move. This command allows to move file or directory from one folder to another folder, or from one directory to another directory. And it allows you rename your file or directory too. The next one, it is Nana. Nana, it's something like that Word, Microsoft Word, or maybe Visual Studio Code, or maybe Sublime Text. It is a text editor. So you can use it to open any text file and change it, and after it, save it. And you can create new file with this command too. So you should just write nana space and directory and file name. The next one, if you create some program, for example, on Python language, you will use Python command to start it. You just write Python space and program name .py. The next one, it is sudo. Sometimes you can't start some programs or actions just like usual user, and you need super user rights. So you will use sudo before command. So if you wanted to feel yourself like a real hacker, then it's time for you. The next slide. Now we will try to use this command and to work with online command line in Linux, because in our drone we will use it to start program, to write program, and to check some parameters, for example. So let's start. The first what I want to do is to see what files or what folders I have now. I should to write ls command and press enter after it. Okay, I see some files there. I don't know what the files because it was the based. So I want to create new directory, for example, and for it, you should write mkdir space and after name for your directory. For example, new directory or new dir any. So if I want to be sure it was created, I can write ls again, and I see it there in blue color, new dir. You can make the same action on your computer, or you can try it later. You have all links in your chat and in chat in Zoom if you want to do it. So after it, I would like create new file in my folder. For it, I should change directory and write program cd and my directory name, new dir, and press enter. If I write there ls, it will empty. We haven't files in this directory yet. To create new file, I should write nana space and name for your program. For example, first program and my program. .py. It means we will create a program in Python language. So let's open it. Now you see text editor area, and you can write something. If you don't know Python, we will show all commands what we will use, and you don't need special knowledge at the first time. But now I tell you some easy moments. For example, if you want print some words or some text to command line, you will use command print, and after it you write double quote, and inside you can write some text. Or if you want, for example, add some numbers, and maybe you have task to multiply some numbers, you just should write these numbers and make your operation with it. For example, we have x equals 5 and y equals 10, and we can easily multiply it, for example. And print command show result in our command line too. Let's try it. To save file and to close file and come back to command line, you should press Ctrl plus X, Ctrl X, and after it asks you, do you want to save it or not? You should press Y. And after it, program asks you should save old name or you want to rename your file. I don't want to rename my file, so I just press enter. Okay, we come back. If we press ls, we can see our Python program and we can start it. We can start it with easy command. Maybe somebody remembers this command. What we can use to start program in Python. You can write it or say it. What command we will use to start the program in Python? Who remember? You can write your answer in the chat. Yes, very good. Oh, Jacques, of course. Okay. I will write Python space and program name. And press enter. So it's show our text, what was in double quote, and it multiply two numbers. So I think now I want to remove this program, and I will use command rm for it, and program name. So press enter, and now our directory should be empty. Yes, it is empty. So if I want to come back to previous directory, I should write cd and two point. Okay, yes, thank you. Now we in main directory. So it's easy, and you will use it today with your team coordinators, and I hope it is clear for you. If not, you can ask me in chat or in Telegram. So I think we give you some time to relax, and after it, we continue. I'll see you in 10 minutes. let's continue. Timothy, are you ready?
Yes, I'm ready.
Very good. Oh, it's a very important moment, yes. I hope everybody come back, and because now I tell how to start use our system, our image, and where you can take it. In a Clover system, we have special libraries and special user interface to easy programming drone. And we have ROS and OpenCV libraries. And it is it's all in one image. And you can just download it and write to SD card and start use. So let's see where you can download it. There is the last version of Clover image. You can download it, but you can write it to SD card only using a special program. For example, we use Etcher, but you can use something else. We have a link to this program too in page on Gitbook. You can use this page to download and write program image to SD card. When it will done, you plug in SD card to Raspberry Pi, and you can simple turn on it, and this image create new Wi-Fi network, and you can connect to this network with password Clover Wi-Fi and start working with command line on Raspberry. And I think it will be clear if all these actions we make with you. But we have this image, and we have a drone. It is ready to you. And now Timothy show you how to create a program, how write code. And after it, I started in real drone on our in our flight zone, and after it you will try to make the same for another mission. Timothy, can you show how to write code and send it me, and I run it on in flight zone on real drone.
Okay. For writing the code, you need to proceed to the page that I showed you previously with this example code here. So first thing you do is copy this code, go into your favorite text editor, code editor. I use Sublime Text, but others are also suitable for that. For example, you can use Visual Studio Code, you can use Atom or Notepad++ or anything you like. And now let's paste the code into our editor. Don't forget to use Python highlight so that you can see it in different colors, and it will highlight you for some errors and exceptions if they are here. Okay, in this code that I told you before, that you have import. You import all the necessary libraries, then you create your ROS node name. The node is actually an object that it interacts with other objects in ROS. And then you provide proxy to services. So these are the services that I can use in my code. And now let's call our first service. I will use navigate To do this, I just write navigate, and in parentheses, I will type in some parameters. For taking off, I will need to provide the height at which I want to fly and some other parameters. But let's see what we have here. The task for us for today is this: take off, then wait for 3 seconds, then navigate to the point 111.5 in Aruco map, then wait there for 5 seconds, then land. This is pretty easy. Let's start. So for taking off, the only coordinate you need to send is Z, because you will take off vertically and you do not need to provide X and Y for that. And they remain 0. And Z will be 1.5 meters. Okay, then let's decide at which speed we will travel. Speed, let's set it to 1 meter per second. This is a safe speed. You can be sure that it will not hit anything too hard. If you will set maybe 1.5 meters per second or 2 meters per second, it may be too fast. So the speed is 1. What else do we need to send? For taking off, do you remember the coordinate systems that are available for us? So here, let's imagine the drone is standing on the floor in a certain point of the field. You can put it anywhere, in any place. It will take off. But when it stands on the floor, it doesn't see markers. It's too close. It just do not fit into the camera angle. Let's assume that the drone takes off from this point, from the point 0, 0. But we still need to provide coordinates in the body frame ID, because it doesn't know where it is in Aruco map. Or even if it does remember some old position in Aruco map, it may be already outdated. So you could move the drone and position will change and be inaccurate. So we always take off in body frame. How do we do this? We just write frame ID. Frame ID means frame of reference. In other words, the coordinate system. And we write body here. So the drone will take off vertically from the place where the body of the drone is located, wherever you put it on the floor. And the last parameter needed for our takeoff is auto arm. So auto arm is necessary to provide once in the first navigate to take off. And we set it to true. It means that auto arm is turned on, and the drone, when the program will be launched, and when it reaches the navigate part, it will tell the drone that if you are not flying, if your propellers are standing still, turn them on, then take off. All right. But the program will not wait until the takeoff is complete. This is important to understand. You need to provide some time for the takeoff to complete. And the time we provide after the navigate. So after navigate, we need to set a pause for the drone for it to be able to reach the height it needs. We do it with a rospy.sleep command. And here we will need to enter some number in seconds, how many seconds we will wait for the next step, before the next step. 2 seconds will be enough to reach the height of 1.5 meters at the speed of 1. It will also need some time to turn on the motors, to take off and to fly to the 1.5 meters. And 2 seconds is enough. But what does our task say? In our task, we need to wait for 3 seconds after we take off. So we need to take off and wait for some more time. How do we do this? We just wait more here. Instead of 2, I will wait 5 seconds. Okay, now I've done taking off, and we need to go to this position 1.5 in Aruco map frame ID. It's so easy. I just write navigate, x equals 1, y equals 1, and z equals 1.5. You might ask me, why do I need to provide z again? Because these coordinates will be relatively to the ground, to the floor. And when I'm already at the height of 1.5 meters, in order to maintain this height, I need to provide z 1.5 in every next navigate when I'm using the Aruco map frame ID. So let's set the speed to be 1 as well, then frame ID Aruco map. And I do not write auto arm true this time, because once it is armed, you don't need to arm it again. Moreover, you must never do it again, because when you do this in the middle of the program, for example, if you have 10 different navigates, each of them has auto arm true, and you want to take over the control of the drone because you made a mistake in your program. You take your remote controller, switch the knob, and you will be in control of the drone, but the program is still running. And if you have auto arm true in navigates, it will take control again and again, and you will not be able to land the drone manually unless the program stops, which may be dangerous. So make sure you never provide auto arm after you have already taken off. Okay, and for this flight, we also need to wait until it reaches the point 1.5. How many seconds do we need to wait? Let's see. Let's look at our picture with coordinates again. I think 1 meter and 1 meter X and Y is maybe somewhere around this marker. And we start from the 0 position. The drone, we will put the drone here. We may start from any position, but we will do it on purpose, put it here. And it will take at least 1.5 seconds to travel to this point. We can provide a little bit more time. So let's give it like 2 seconds to walk from here to there. And also what we need to do is wait once we have reached this point, wait for 5 more seconds. It's so easy. I just say ROSPY sleep for 7 seconds, 2 for reaching the point and 5 just for waiting. And now land. As it is the function, you need to leave a blank parenthesis. Okay, the program is ready. I need to check the spelling and everything else in order to be sure there's no errors. I think it looks fine. And now we can test it in our environment. We have Gazebo simulator and we have the real drone. First, let's try it in the simulator because it is more safe and easier to just start. I have already opened the simulation virtual machine. And here in my terminal, I have a folder called code. And let's create a new file. I could just create it manually from here, but let's train some more Linux console. So nano, and let's call it test flight.py. Enter. It opens nano, and here with Control-Shift-N-V, I paste this text of the program. I can check out if there's everything we need, and Control-X, then Y, then enter. ls. The program is here. I called it test flight.py. Now let's run the Gazebo simulator. It's pre-configured to be working with our drone, and I have already generated a field with markers so that I do not need to generate it again. And once it launches, we can start our program. Okay, this is it. I will change the camera view to orthographic because it's a little bit faster. And here is our drone standing and waiting for the command. Here you can type localhost and find some videos, live video stream from the camera, and I will show you how it works once we take off. Let's run our program. Python test flight.py. I do not need to type it manually. I just type TE, then press tab, and the console auto-completes my type. Now I run this program, and let's see what the drone will do. I think you can already see that the propellers are moving and it's about to take off. I need to notice that this simulation is slowed down a little bit because of performance. It requires a lot of computational power to work smoothly and seamlessly. But when it's not enough, the simulation will be just slower. And let's see the camera. Let's see our camera picture. Yes, you can see the drone sees all the markers and is moving to this point. You can also look at the ARC detection. So the drone detects all the markers, and you can see it outlines them and navigates that way. It reaches the point we provided here, 1.5. It's waiting for 5 seconds, and it will land now. The actual speed of the simulation right now is about 20% or even lower. So it will be faster in real life. Okay, the drone landed. The program works. Now I can send it to Julia for testing it on a real site. Okay, Julia, are you here?
Yes. Let's run this program in real drone. Now I'm on the fly zone, And I think I can share a screen from cameras from flight zone. Как в Zoom здесь расширить? Второй.
I sent the program to Zoom chat.
Yes, one moment. So there is a flight zone, and at first I would like to check drone keep his position in one point, because if we have Aruka maps and drone see Aruka markers, it can calculate his position accurately, and it can keep his position in position fly mode. So let's try it. Our team will help me. Take off.
Hi, I will be a personal commentator and journalist from our polygon. And now, drone holds their position in one point using position mode. For example, if we move on to another point, drone will come back to again to initial position. And this mode has demonstrated a very good position using Aruka map markers in indoor navigation frame. Thanks, Yulia. It was a great. Please suit up. Alexei, thanks for saving our drones. And Alexei changing the mode to manual.
So our drone keeps his position. And now we can start your program, what Timofey wrote on his computer in real drone. So Timofey.
Yes.
Share your code to, okay, I see it. Very good, thank you so much. In one moment. I just copy code from Zoom chat and create program there. I think I forgot one moment. We should connect to Clover network. This computer knows password, but if you connect to this network it's first time, you should write password Clover Wi-Fi. So, okay, it's connected. I restart session. It's asked me write login and password. Password is Raspberry, but when I input password, nobody see symbols, because it is a special security system of Linux. So don't worry, it's okay. You can just write Raspberry and password field and press enter. And password from Wi-Fi and password from Raspberry. in main chat. So now I create new program. I call it our flight. And don't forget .pi. And I just input code there. Okay, it's ready. To close this file, I press Ctrl X, Y, Enter, and I ask my colleague Alexei to be saver our drone, because if we have some mistake code, and if drone if drone will make something unpredictable, we take control from Raspberry Pi to a remote controller and continue fly with manual control. But if you're ready, let's start. I write Python command and I write only two letters, and after it I press tab, and system continue this word if this file or folder exists. So you can just press tab and don't write all words or name of file. So are ready? Let's start. And after it, it's fly to coordinate. So Alexei shows remote controller now. He don't touch it and don't fly. Very easy, I think, and I hope it was clear for you. But we have a task for you for today. It will be a little bit harder, but I'm sure your team coordinators will help to make it. So now you will add you change this Zoom conference to another what will be sent to chats from your team coordinators, and you have this task at the screen. You should take off, and after it's fly to point 1, and after it's fly to point 2, and after to point 3 and 4, and after it you should land. So it is the same. It will be the same program like we wrote now, and I'm sure you can make it. And when you check it on workstation on Raspberry with your team coordinator, you can send it to Flight Zone, or you can send it to Timofey Kondratiev, and we check it in simulator Gazebo, or in real on real drone in Flight Zone. So let's start. I hope our team coordinators they will send you new link to Zoom. Zoom with your team coordinator. You should connect there and start work. And in this link, in this Zoom, already will general phone, main phone, where you can see Flight Zone, where you can see terminal and command line, and you can see their task. All what you see now, you can see when you connect to this link, to this Zoom. Okay, good luck.
Hello everyone. Today we are relating about performing the first task. Our teams from Brazil, Barbados, Ecuador, Portugal, South Africa. They need to write their first program for the first autonomous flight, and they need to perform autonomous flights point to point. So they will perform takeoff, flight to point number 1, number 2, next number 3, next number 4, and finishing by landing. It's very simple task, but this exercise helps them to get their first experience in drone programming and communicate with our team coordinators and send and share their code to the control station. When it will happen, you will see how drone performs the autonomous flight.
Hello.
Bruno, it's your program.
Ecuador. Nice you.
Hi guys again. How are you? How are you doing? How was your experience for today?
Hi. Yeah, that was really good. We learned a lot.
Great, great. Nice to hear it. So we wait 2 minutes, I think, and make a finish our our classes for today. Great, great. So have you a flight? Have you an autonomous flight? All teams have an autonomous flight. It's an amazing day. Yes, of course. And the next days will be amazing more. More flights, more amazing mood. While we waiting our another participants, who would like to share their experience for today? It can be using our live stream. Who would like? No one to share their expectations of these days or their impressions of this day.
Me. So it was so incredible. I like it. I love it.
One love. Drones is one love.
Yes, this is the word. Changed my perspective of how to see the drones, because I only drove race drones, and this type of drone is different for me.
Yeah, we have in our team we have Vladimir. He is a professional drone racer, and also he have changed their focus on autonomous drones too.
Yes, it's so interesting.
Yeah, because it's a new area, new skills, new knowledge. It's all interesting, of course. And I think we can start our briefing. So first of all, I would like to give to give opportunity to say their expression, their impression from their lesson. Let's welcome our teachers, Yulia and Timofey. Please tell us how was your first day, please, finalists, and we will continue next.
Well, I liked to work with you, and I'm impressed how quickly you have made your first results, because what we've taught you, it's not so easy to understand from the first time. And all of you have written your programs and you fly it, you run these programs on simulator or on a real drone. Some of you even tried to install the simulator on your own machines, which is great. I think it is what you need to do to practice more. And we are here to help you with this.
So, surprised results today because it was really good. I don't think you can make all tasks so fast, and a lot of your team make much more than we asked you today. And my congratulations for it and for finish your day. It was really great for us to see your successful.
Okay, thanks our amazing teachers for this amazing day, and also I was surprised how you passed, how you performed your first task. It was very quickly and very maybe professional. Maybe you have a good talent to autonomous drones. And also I would like to say thank you, many thanks to our team coordinators. This team was I think this is a superhero who help us, who help you to get perfect experience in autonomous drones. And so as a finish of our day, before finish, I would like to, I have an offer to you. We would like to get from you reflection. It is a simple question about how was your day and what difficult, what issues was confused with you. And our team coordinator will share a link in your private group team. It takes not more 5 minutes. Please fill this form and it will be great for us. So, and finally, we have an amazing photo. This is amazing photo for all of us. This photo will be daily tradition, daily routine. Thanks you for hard work, and see you tomorrow at 4 o'clock in Moscow time. See you guys. Bye bye.
Okay, Svetlana. Thank you so much. Bye, guys.
Thank you so much. Bye.
Great. Bye.
Thank you. See you later.
Thank you. Goodbye.
Yeah, amazing meeting. Bye bye.